Hello everyone, my name is Kingsley Idoko and I want to welcome you to my YouTube video on Inter-vlan routing with the ASA. In this video, you're just going to play a little bit with the ASA. This is topology I'm going to be using for demonstrating how they can implement that. So as you can see, this is like a data center network for Acme. Let's say you and I will work for Acme, and then we are given the task to build the data center and also to implement inter-vlan routing. So basically, as you can see, we have 4 devices on this network. We have 2 servers, one ASA firewall, and we have a switch that is just a layer 2 device. So, basically companies these days, you collocate somewhere in the data center and you have your devices. And so what we need to do is build this network and then also see how we can implement inter-vlan routing. Now, why would you want to implement inter-vlan routing in this kind of topology? Now, it could be for any reason, maybe compliance, could be for security reasons. You have the finance and the marketing. You are asked to separate the servers into 2 separate networks. So as you can see here, I have the 192.168.20.0/24 subnet. I also have the 192.168.10.0/24 subnet. Finance server has a gateway of 10.1. Marketing has a gateway of 20.1, and the ASA goes to the internet. Now we have different type of traffic that flows through this network. I try to show them here, like the red indicating traffic between I call it the east-west traffic. It's traffic between the finance and the marketing department. For the green dotted lines, you see that's for finance server internet traffic. So for traffic for finance to the internet. For marketing, it's a little bit of dark blue. I don't know if this is dark blue, but it's for traffic for marketing to the internet. While the red, of course, is for traffic between the finance and the marketing. Now the requirement says traffic between the finance and the marketing department should go through the ASA. It could be for any reason, right? Finance, they deal with a lot of money, right? So those data are very sensitive, and so you don't want free flow between finance and marketing. So let's say this server gets compromised. You don't want an attacker to be able to use this marketing server as maybe a launch pad to go to finance. So we are going to implement some kind of policy to ensure that traffic between the finance and the marketing goes through the ASA. Now, in terms of the physical connectivity, you see the dark line shows the physical connection. So we have one connection from the ASA to the switch. We have one connection from the finance server to the switch. We also have one connection from marketing. Now, for traffic to go from finance to marketing, it has to first of all hit the ASA and then route back to the marketing. Now, this switch is a Juniper switch that I'm going to be using here, Juniper QFX switch. Very simple to use. You don't have to use Juniper. You can use Cisco. You can use Arista. And there's a bucket load of other vendors equipment that you can use. But like I said, the focus here is on the ASA. Now, going to the topology, this is the actual topology for what I show you here. As you can see, I have the ASA. I'm using Pinet Lab. You can use Eve. You can use GNS3. Depends on the one you're comfortable with. I use Pinet because it's very easy to get the images, because you can just download directly from the server the images. They have their own images repository, so you can easily download them. I don't have to go to Cisco site or Juniper to get images for those devices. If you're looking for how to do that, I think they have some videos on YouTube. You can check how to set up Pinet Lab. I really love Pinet Lab. Though it's similar to EVNG. So I already have these devices powered on, as you can see. So this is my ASA. This is my Juniper switch, QFX switch. Now for the Juniper QFX switch, you can see there are actually two devices. There's a separation between the routing engine and the forwarding engine. So this is I think this should be the forwarding engine. This is the routing engine. It's kind of upside down, right? Because you would think the forwarding engine should have the physical connections, but that's not how it is. The routing engine has the connections, while the forwarding engine, it's just there on its own. Yeah. So that's how the Juniper devices work. Now, if you want to see if the forwarding engine is actually connected to the routing engine, you just say show chassis FPC. So you can see it tells you on slot 0. Yes, it's more like, I think it's more like saying on slot 0 there's a line card, right? So, and it's online. So it means the way it is now, you can forward traffic. So I have the finance and marketing. These are just virtual PCs. You can get them here. If you go to nodes, so it's always there by default. Just some light devices. So what do we need to do in this topology? So first, we're going to start with the ASA. We're going to create our sub interfaces. We're also going to fix the internet connectivity to make sure the ASA can ping the internet, at least ping Google 8.8.8.8 and 4.2.2.2. And then we also make sure that the finance and marketing can also get to the internet. That's the first part. And of course, we need to create VLANs on this QFS, pass the VLANs. The interface that goes to finance is going to be access port, maybe on VLAN 10, and this interface is going to be an access port as well on VLAN 20. Why this interface is going to be trunking towards the ASA. It's really, like basic stuff that we just need to do. So let's begin with the ASA. So I'm just going to go to the global mode, and let's set the host name, right? I'm just going to say host name is going to be ASA firewall gateway, if you want something like that. Let's check the connect the actual ports. So this is G0/0. So I'm going to come here and say interface G0/1, hit no short, interface G0/0, bring the physical port up. So let's fix the outside interface, right? So I'm going to say interface G0/1. First, you're going to give it a name if, which is outside. Right, it gives it automatically assign a security level of 0 because it's an untrusted part of the network. And so we need to give it an IP. Now, when you're doing this on what's it called, on either Eve or EMV, or I think it's still the same. So this is the actual Pinet server, the OVA, and you see this is the IP it has, which is 192. I can't show my cursor, but it's 192.168.85.130. So I'm just going to give my ASA 131 because it's actually connected to that same LAN, right? So I'm just going to give it IP address to 192.168.85.140 and 25.25.25.0. No shots, we already enabled the interface, and so if I do show run interface G0/1, everything should be cool. So I should be able to ping 192.168.85.130. Okay, so that works perfectly. And so we need to give it a static route, right? Default route. So I'm going to say route outside. So anywhere I want to send it to 192.168. Let's just give it to the VM 85.130. Yeah, so show route, you should see that route there, and I should be able to ping Google. I should also be able to ping 4.2.2. Fantastic. So from the ASA, we can reach anywhere on the internet. So now let's focus on the inside interface. So we need to create two sub interfaces. First is for VLAN 10, and the second is so let's just finish the VLAN 10. So it's going to be name if, it's going to be finance VLAN 10. right? So it gives it, because it's not inside, it's going to give you the security level of 0, but we need to make it 100 because it's trusted. And the IP address is going to be 192.168.10.1, 255.255.255.0. So show interface G0/0.10. Fantastic. So we also do the same for the 20, right? VLAN 20. Name if should be we call it marketing VLAN 20. Security level should also be 100, and IP address this time should be 192.168.20.1, 255.255.255.0. No shots. So if I do show interface IP brief, so we have everything sorted out, right? So with this now we now have you know, here we are using private IPs, and this service needs to go out to the internet. So what do you need to do? We need to do nothing, right? So I'm just going to do NAT at the configure the NAT, implement the NAT translation on the ASA. So to do that, let's create the network objects, right? I think that's the best way. Network objects, not network objects, say object network. The name is 192.168.10.0. I'll just say this is /24. Description, I will say this is finance network. IP, so the subnet is going to be what, 192.168.10.0 255.255.0. Why didn't just allow us to put /24 there? And then yeah, so we can just do the NAT here, right? Say NAT finance VLANs to outside. I'm just going to say interface, dynamic interface, right? So if I now do show run objects, so we have that there. And if I say show run pipe include NAT, you see it's actually there. So let's do the same thing for marketing, right? So objects network 192.168.20.0/24. Description here is going to be, say, marketing network. Okay, then the subnet is actually going to be 192.168.20.0 255.255.255.0. And then we can also implement the NAT and say this is for marketing VLAN to outside. It should be dynamic interface. So what that is saying is if the traffic is coming from finance and it's going to the internet, just NAT it to the outside IP. So in this case, our outside IP is 192.168.85. Yeah, I'm on the ASA. So if I do show interface IP brief, so it's going to be NATed to this, right? And so it's NATed to this, and it gets forwarded to the host VM, which with that, I think the internet should work. Now, so I think we are done with the ASA for now. So let's move on to the Juniper. Now for the Juniper, let's say the interface. I'm just going to say show configuration interfaces, pipe display sets. Ooh, a lot of interfaces. So we should just delete the interfaces and create the ones we need, right? Now I can just come and say delete interface, but don't do this, because when you do this, it's also going to delete the interfaces that connects the routing engine to the forwarding engine. Remember these interfaces? Yeah, so if I should use the command delete interface, it's going to wipe out everything, but we don't want to delete this. Or you can of course say delete interface and then configure this, but I don't want to do that. So the best way to do it is to say wildcard, delete interface, xe0/0/ you put your range, so from 0 to, so you see here it's 71, right? So I'm just going to say 90. Let me say 90. I have my reasons for that. Hit enter. Yes. Now there's also some other interfaces, which is the ET. I think those are for the Ethernet. I'm not sure what those ports are used for, so I'm also going to do ET here. Sorry, should be ET. Yeah, so yes. Then I'm going to hit commit, and let's wait. Yeah, you can have some delays because this is actually a virtual device. Good. So if I do run show interfaces, you can come and say pipe display sets, run show configuration interfaces, and pipe display sets are only fantastic. So I've taken off all the interfaces that's just there and not doing it. So now let's create our interface, right? So I'm going to say set interface xe0/0/1, unit 0, family should be Ethernet switching, interface mode should be access, right? And okay, so we need to create the VLAN first, right? I just remember set VLANs. Let's call it finance, VLAN 10, VLAN ID should be 10, set VLANs marketing, VLAN 20, VLAN ID should be 20, right? So show pipe compare, so we already have that, so we can now tie it to the interfaces. So set interface xe0/0/1, so 1 goes to the finance, right? Unit 0, family should be Ethernet switching, interface mode should be access, and then you can say VLANs member should be 10, right? So the next one is going to be 20, and it's going to go to xe0/2, right? And the other one is going to be trunk. So let's just fix everything here. So you're going to be trunk, and which is the x0/0/0 interface. So this is the interface going to the ASA. It's going to be trunk, spell it correctly, and the VLAN member is going to be 10, 20, right? So if I do show pipe compare, so I believe with this we are good with the QFX switch. So I have the configuration. So on the interface going to the ASA is going to be trunking, and we're allowing VLAN 10 and 20. For the finance, VLAN 10 for the marketing is, so we can as well add description. I think if you want us to add description, let's do that, right? Set interface xe0/1. I believe I can put description. I'm just going to say connection to finance. So finance underscore server, right? Just to make it beautiful. And then is after the finance, yeah, it's correct. Then also, so the second one will be to the marketing. marketing. This goes for interface x0/2, and the last one is going to be uplink to the ASA. Let's call it uplink to ASA, and this is going to be 0. Show pipe compare. So we have a description there, makes a lot of sense. So I'm going to hit commit. Okay, so I mean, with this, I think everything is good now. And so we just need to assign IPs to the finance and marketing, and I hope we can ping the internet. Commit. So so for the finance VPC, I'm just going to say IP 192.168. So I'm just going to give it an IP 10.10/24, and the gateway is 192.168.10.1. Okay, while that is checking, let's also check for marketing. IP is going to be 192.168.20.20/24, right, and 192.168.20.1, right. If all is good, at least we should be able to ping the gateway. Ping to 192.168.10.1. Ooh, that's so cool to see that's working. So for marketing as well, ping to 192.168.10.20.1. Yeah, fantastic. So at least we know that connectivity from the servers, I prefer to use here, I think we know connectivity from the finance and marketing can get to the ASA, but can we reach the internet? We should be able to reach the internet since we've actually configured NAT, right? So I say ping to 8.8.8.8. It's not working. Now, if you want to be sure what is actually going on the ASA, maybe there's some inspection that we need to add. So I'm just going to go to the global mode and say login, enable. I'm going to say login console at 7. Please don't do this in production. Okay, don't do this in production, because it's going to overrun the buffer, and you won't be able to do anything. So let's see, is there translation already going on? I think it's show xlit. See, so show nuts. Okay, I'm seeing some auto NAT policy here, right? So it's from finance to outside, the dynamic interface translate hit 0, hit count is 0, but for this there's a hit count, right? So for marketing there's actually be translation. So but what is wrong? Let's try to ping again and see what we see on the log. Yeah, I think I'm already seeing some deny, right? So basically you need to I think the ICMP behaves separately or differently compared to other protocols like the HTTP. By default, the ASA does not inspect ICMP. And what we just need to do this, I think there's a command say fix up protocol ICMP. So when you do this, it should now automatically inspect ICMP. So if we do this now, ooh, this is really great, right? So I'm also going to say ping to 8.8.8 from finance, so we have access to the internet. Isn't this interesting? Yeah, it is. So I can also ping 4.2.2.2, and I can ping anywhere on the internet, right? Yeah. So now, how about if we try to ping between the two servers, right? So I'm going to say ping to 192.168.20.1. It's not going to go there, so I can't even ping the gateway. So we fixed, so let's look at what we've achieved now. So we fixed the connectivity to the internet for both servers, right? So this we are good, the green we are good. Now we are focused on the east-west traffic between the ASA. We've said we don't want it to go between directly through the switch. We want it to hit the ASA. Now, I mean, if it was a router or a switch, and you create two sub interfaces, definitely it's going to route automatically between them. But for the ASA, like I said, the ASA behave quite differently. The ASA, when it receives traffic through an interface, it will not automatically send that traffic back on that interface to the destination, right? So when the traffic hits the ASA does a lookup, right? Like an app, or how you want to call it, a route lookup, and see that, oh, it's actually back to the same interface that, you know, the request came from. But the ASA by default will not so let's look at it this way. So I do a ping to this. First it gets to the gateway, because the server says, on the server we said, oh, your gateway is where 10.1. so here's the ASA, and the ASA has to do a lookup, right? And say, okay, how do I get to 20.20? Is it in the routing table? Yes. But how do I get there? Now he's going to definitely do the app request, right? To, you know, learn the MAC address and then forward. But in this case, you see that because they are coming from the same interface, right? It will never forward that app request back on the same interface that, you know, you are getting the request from. So that's that's the reason why by default the ASA it will not just route between two sub interfaces with this that have, even if they are different, of course they have of different VLANs, right? So what we need to do here is a command we need to run that says, now before I even get there, you also quite know that for the two sub interfaces, let's just say show run interfaces. You see they are even of the same security level, right? So VLAN 10 and VLAN 20, they both have they both have the same security level. So you would expect that since they are both secure, traffic should be allowed through. No, the ASA doesn't work that way. You will need to, you know, tweak it to tell the ASA, you know, for traffic, even if they are of the same security levels, you still need to explicitly say the traffic should be allowed. So I think the command here is same security traffic, right? You say permit. Now you have two options. One is in inter-interfaces and the other one is intra-interface. Now what is the difference? Now let's say I have two interfaces, right? Let's say on this ASA we have another interface, maybe the one that goes to a DMZ network, right? And these two interfaces both have security level of 100, right? Now, even if the security level, even if they are on the same level, traffic will not flow through both of them without a policy. There has to be a policy that says traffic coming from this interface going to the DMZ should be allowed, right? Even if they are of the same security level. Now, if they are not of the same security level, just like you have from internal to outside, you know the traffic is allowed by default, right? So I'm coming from a secured domain going to an untrusted network, the traffic is allowed. But if you are coming from an untrusted network coming down to a secure network, by default the ASA is going to deny it, right? In fact, that's the whole idea of the firewall and the stateful inspection, right? Because I do a ping to 8.8.8.8. The firewall is going to see the traffic and keep track and say, oh, you're coming from a secure domain to an untrusted network, right? But since you're coming from a secure domain to an untrusted network, that's not an issue for me. So the ASA is going to allow it. But when the ICMP reply comes back, it's going to say, oh, you are coming from an untrusted network to a secure network. So the ASA by default is going to drop it. But because of the stateful inspection, the ASA knows that, oh, this servers actually, the traffic actually originated from my internal network, so I'm going to allow it. right? But for when there's that stateful inspection, then traffic that goes out, that originates from the internal, goes to the internet, is allowed backend. But if I'm on the internet and I'm trying to reach this server, by default it's not going to be allowed, right? Because it's not originated from the internal, it's coming from the untrusted. So there has to be some kind of policy, like an access list that will explicitly what, allow that traffic. So back to what we're discussing, that's the difference between intra and inter interface. Inter means I have two physical interfaces. They have the same security level. Then I want to allow traffic without any rule, right? But for intra, this is what we need to use, because intra means within the same physical interface, and that is what we have here, right? So in our topology we are both using interface G0/0, but we are tagging it with VLANs, right? So that makes it intra. So that's what we need to add here to say intra interface, right? Yeah, I think that's all you need to do. So once you enable that, it means I think they call it help pinning. I can't really remember, right? It's more like what they call help pinning. You can as well apply it on the outside interface. For example, you could have users who are working from home, but you still want them to connect through the VPN to go to the internet. So what happens from the internet? The traffic hits the ASA, it goes through the different security policies, and then it goes out to the internet. In such way, even when users are not connected internally to the ASA, even from their home, we're still able to provide the kind of security compliance that we want to have for them. I think there's an implementation called the help pinning, and I think this is the command that actually makes that to work, right? So yeah, so with this now, I believe Finance should be able to ping okay, so let's see. So we are still not able to ping 20.1, but let's see, can we pick 20.20? Let's see, we're still not able to. Right now, let's go to the ASA and see what is going on, right? So I still have some deny, right? Same security permit in trying interface, but I still see some deny. So what is the deny? Deny says deny ICMP from 192.10.20 to destination with the type it. So let's see, why is it being denied? Even if so, I think we might also need to still add this. Let's just see if this is the problem. Same security permit interface. All right, I think it looks like we need both of them for it to work. Let's see. Yeah. So okay, so from what I see here, the two VLAN are two separate interfaces, right? So maybe that's what we actually needed, not the intra interface, right? Okay, so to be sure, we're all learning. So let's see. So what I want to do now is I want to say no same security permit intra interface. Okay, so that is no longer there. Let's see, does it still work? Yeah. So what we actually need is the intel interface, right? So even if it's the same physical interface, because they are sub interfaces, and you want to allow traffic between two sub interfaces with the same security level, so that is the command you actually need, right? So this is not what you need. This, I don't know the scenario now. I'm trying to think of what scenario you want to use this, but the command we actually need is the intel interface. All right. So I hope you learned something from this video. We did some little play around for the ASA, and In my next video, what I'm going to do is I'm going to build what we'll do on the next video is to build remote access VPN on this ASA, so that users who are working from home can access, so people from finance should be able to access their services on the finance server. People from marketing should be able to access the application running on marketing server. All right, so that's what I'm going to do next, which is to build the remote access VPN using the we're going to build both for the, I think we'll just build for the AnyConnect VPN client, right? So we're going to create some tunnel group, create some group policy, create some local pool, and then we'll see how things works, right? So thank you so much for this video. If you like it, you can subscribe for more videos. See you next time. Thank you.